Welcome to today's forum discussion on high voltage power lines and electromagnetic interference EMI. I am NURUL and I will be the moderator for today's session. High voltage HV transmission system is an important concept in modern electronic power network where large amount of electricity can be transferred over long distance with minimal losses. However, HV transmission systems are particularly vulnerable to electromagnetic interference EMI due to their scale configuration and operational environment, which degrade the performance of the system and compromise safety. Today, our panelists will be discussing the technology of high power lines and electromagnetic interference EMI, the literature and applied concept of the electromagnetic in this technology, the impact of the implementation and possible solution to address the impact. Our first panelist is Ms. ABIEY, an electrical power engineer. Our second panelist is Ms. FARAH NABIHAH, an academic researcher. Our third panelist is Ms. SOFIYA, an environmental health and safety engineer. Finally, our fourth panelist is Ms. NURULAIN BASIRAH, a system optimization engineer. Please join me in welcoming all of our panelists. To begin our discussion, it will be nice to first understand the technology itself. High voltage power line, which become the core to our modern power system. High voltage transmission lines are often seen as simple structure carrying electricity across the country. However, behind their operation lies a fascinating application of electromagnetic theory. I would like to invite Ms. ABIEY to further explain the technology.
So, Assalamualaikum and very good day to everyone. First of all, I would like to thank Ms. AYUNIE for giving me the opportunity to share my thoughts on this topic. High voltage power transmission lines, which are used to deliver electricity from power stations to homes, industries and businesses over long distance. This technology uses the principle of electromagnetism. When a high voltage is applied to transmission line, it creates an electric field around the conductors. At the same time, the flow of electric current generates a magnetic field. Together, this forms an electromagnetic field or EMF. However, these electromagnetic fields can also cause electromagnetic interference, also known as EMI. EMI occurs when the electromagnetic energy from power lines affect nearby electronic devices, communication system or electrical equipment. Research show that the electric field strength depends on the voltage of the transmission line, while the magnetic field depends on the current flowing through it. The electromagnetic field becomes weaker as distance from the power lines increase.
Based on your explanation, would you say that the benefit of high voltage transmission line outweigh the challenges caused by the electromagnetic interference?
To conclude, the benefit of high voltage transmission line outweigh the challenges of electromagnetic interference. They are vital for efficient electricity transmission and economic development. While EMI can create certain risks, this can be managed through proper design and safety measures, making high voltage power lines an essential and sustainable technology for modern society. Thank you.
Alright, thank you Ms. ABIEY for the insightful explanation. From your presentation, we can understand that electromagnetic fields are not merely byproduct of transmission lines but are actually fundamental to the process of transferring electrical energy efficiently over long distance. However, understanding the technology alone is not enough. We should also examine what previous studies have discovered regarding this application. Therefore, I would like to invite Ms. FARAH to share findings from literature studies.
To our previous panelists for explaining the technology of high voltage power lines and its role in modern power transmission. Building on the explanation, I would like to continue by presenting findings from literature studies discussing how electromagnetic concepts are applied in this technology. According to electromagnetic theory, whenever electrical current flows through a conductor, electromagnetic fields are naturally generated around it. This field consists of two components, which are the electric field and the magnetic field. The electric field is produced due to the voltage applied to the transmission line, while the magnetic field is generated by the movement of electric current through the conductor. Since high voltage transmission lines operate using alternating current or AC, both fields continuously change with time and combine to form what is known as an electromagnetic field or EMF. Literature studies further explain that most power transmission systems operate at approximately 50 Hz, which falls under the category of extremely low frequency electromagnetic fields. These fields are classified as non-ionizing radiation because they do not carry sufficient energy to directly alter molecular structures. Researchers also found that electromagnetic fields are not simply a side effect of transmission systems, but are essential in enabling the transport of electrical energy from generation stations to substations and finally to consumers. Therefore, the operation of high voltage power lines demonstrate how electromagnetic concepts are applied in re-engineering systems to support stable and efficient electricity transmission.
From the literature study that you reviewed, what would you consider the most important of electromagnetic field in high voltage transmission system?
Literature studies shows that electromagnetic fields form the fundamental operating principle behind high voltage transmission technology and play an important role in ensuring reliable power delivery. Thank you.
Thank you, Ms. Farah, for the explanation. Your explanation highlights an important point, which is electromagnetic fields are not accidental occurrence within transmission system, yet they are an essential component that makes electrical power transmission possible. While electromagnetic principles enable efficient power transmission, they have also generated concern regarding their effects on human, technology, and the environment. This brings us to our next discussion. I would like to invite Ms. SOFIYA to discuss the impact of high voltage power lines and electromagnetic interference. According to your research, are there any risks to human health, electronic devices, and the environment?
Alright, thank you to the moderator for inviting me to this forum discussion. As for my part, I will discuss the impacts of electromagnetic interference or EMI in high voltage power transmission systems. While these transmission lines provide many benefits such as sustainable development by helping to distribute electricity over long distance, they can also create electromagnetic interference or EMI, which may affect both people and the environment. However, EMI can affect protection and automation systems that keep the power grid operating safely. One example is false tripping, where a protection relay incorrectly detects a fault and disconnects a power line even though there is no actual problem. EMI can also cause a failure to trip where the relay fails to detect a real fault. This may lead to equipment damage and safety risks. The second impact is on human health. High voltage power lines generate electromagnetic fields or EMF, which are classified as non-ionizing radiation. Although they do not directly damage human cells, some studies have suggested possible links to sleep disturbance, stress, and an increased risk of childhood leukemia. However, no direct relationship has been proven. EMI may also affect the environment. It can interfere with the navigation of migratory birds and sea turtles, creating buzzing noise from transmission lines. Additionally, strong EMF that has been exposed to domestic animals over a long period will cause changes in behavior and physiology of the animals. Other than that, plants are also sensitive to EMF, and it will change the growth of certain plant cells, and medical devices and communication system also all will be affected.
Alright, despite these potential impacts, would you still consider high voltage transmission system safe for public use?
As for me, high voltage power transmission systems are generally safe and essential for modern society with the proper shielding, grounding, and regular maintenance. The effect of EMI can be minimized while ensuring a reliable electricity supply. Thank you.
Thank you, Ms. SOFIYA. Your presentation has provided concern associated with high voltage transmission system. We have learned that while EMI may affect protection system, communication equipment, wildlife, and potentially human well-being, the scientific evidence currently suggests that these systems remain generally safe when designed and operated according to established standards. Despite these impacts, the way to improve safety and reduce potential risks are important to be viewed, even though the impacts are significant and minimal. This leads us to our final part of the discussion. I would like to invite Ms. NURUL to present the solution for reducing the impacts on the society and the environment.
Thank you, moderator, and thank you to panelists too for clearly laying out those critical challenges. To ensure our high voltage transmission system remains sustainable, efficient, and socially responsible, we must match every grid, health, and environmental risk with a concrete engineering solution. Here's our strategic mitigation framework. First, to eliminate the severe risk of protection relay false tripping or failure to detect actual faults, we must upgrade our substation microprocessors with advanced smart digital signal filters. These filters automatically isolate the main power frequency and completely reject high-frequency electromagnetic interference noise. Additionally, traditional copper data lines should be replaced with optical ground wires because fiber optics transmit data using light. They are naturally immune to electromagnetic fields, completely preventing communication corruption. Second, to safeguard migratory birds, sea turtles, domestic animals, and nearby plant cells in ecologically sensitive zones or dense agricultural areas, we should transition to underground shielded SLPE cabling. Placing the lines underground combined with continuous metallic cable shielding acts as an absolute barrier. It safely traps and grounds out the magnetic fields into the earth, keeping the ground surface completely isolated and safe for the surrounding ecosystem, nearby medical devices, and communication networks.
Alright, as we wrap up this discussion on electromagnetic mitigation, Ms. Nurul, what is your ultimate takeaway on how we can make high power harmoniously coexist with the world around us?
In my point of view, by combining digital signal filtering, phase cancellation, geometry, and strategic underground shielding, you can deliver high voltage power that safely and harmoniously coexists with our communities, our technologies, and the natural environment. Thank you.
Alright, thank you, Ms. Nurul. Your proposed solution demonstrates how engineering innovation can be used to address EMI challenges without compromising the efficiency of power transmission system. Particularly interesting were the recommendations involving smart digital filtering, optical ground wire technology, and underground shielding cabling. These solutions show that many EMI-related issues can be managed through thoughtful design and technological improvement. As we come to the end of today's forum, let me briefly summarize the key points discussed. We learned that high voltage power lines are an important application of electromagnetic principle, allowing electricity to be transmitted efficiently over long distance. Literature studies also show that electromagnetic fields are fundamental to the operation of this system, but they can also contribute to electromagnetic interference EMI. Our panelists discussed the potential impacts of EMI on electronic system, human health, and the environment. While concerns exist, high voltage transmission systems are generally considered safe when proper engineering standards and maintenance are applied. Finally, we explored several solutions including digital filtering, optical ground wire, and underground shielding cabling, which can help reduce EMI and improve safety. In conclusion, high voltage power lines remain essential for modern society, and with continuous technological improvement, their benefit can be maximized by minimizing their impact on the environment. On behalf of the group, thank you to all the panelists and audience members for your participation and attention. Thank you and have a pleasant day.